integrating natural language processing with visual narrative for multimodal communication. The integration of natural language processing, NLP, with visual narrative represents a significant advancement in multimodal communication, enabling systems to generate and interpret human-like stories across visual and textual media. This convergence reflects both a technological evolution in machine understanding and a theoretical shift in how narrative is conceptualized within digital media environments. Visual narrative, broadly defined as the structured sequence of images conveying a story, finds new dimensions when coupled with the interpretive power of NLP systems, which offer tools for semantic analysis, emotional tracking, text synthesis, and linguistic coherence. The domain has grown through several foundational efforts. The development of datasets such as VIST, visual storytelling, has allowed researchers to train and benchmark models on image sequences annotated with human-authored stories. Models like GlockNet and VIST GPT build on these datasets to implement sophisticated attention and coherence mechanisms, aiming to replicate the human capacity to craft flowing and emotionally resonant narratives. However, early models often struggled with maintaining character continuity, resolving coreference, and generating narratives that reflected believable emotional arcs. These issues are now being addressed through architectures like Vi-Enter, which integrates emotion arcs into narrative generation, and multimodal transformers that incorporate visual embeddings and common-sense reasoning to enhance semantic depth. The convergence of NLP and visual narrative mirrors broader shifts in digital media toward multimodal communication. Transmedia storytelling, media convergence culture, and the proliferation of interactive media formats necessitate systems that can process and generate content across modes. NLP plays a central role in this landscape, transforming visual signals into text, aligning multimodal inputs, and generating commentary that enhances audience understanding. Large vision language models, LVLMs, and instruction-tuned systems, such as StoryLava and MiniGPT-4 offer evidence that high-level narrative reasoning is becoming more accessible through foundation models, although questions of generalization, creativity, and ethical modeling remain unresolved. Despite these advancements, the literature reveals substantial gaps that define future research directions. One persistent issue is the lack of generalizable common-sense reasoning in current models, which often generate plausible but shallow narratives. Additionally, visual storytelling models frequently lack coreference coherence and struggle with narrative logic across sequences. Most existing datasets remain domain-constrained, and evaluation metrics fail to capture subjective aspects such as emotional fidelity and cultural resonance. Theoretical integration is also limited. While narratological models exist, few are systematically incorporated into machine learning pipelines, and fewer still are informed by cognitive neuroscience or visual semiotics. Future interdisciplinary research must address these gaps by developing hybrid symbolic neural models that blend narrative grammar with generative capacities. Creating larger, more diverse datasets will allow models to generalize beyond narrow storytelling domains. Ethical storytelling frameworks and interpretability mechanisms will be necessary to ensure culturally sensitive outputs. Moreover, incorporating neurocognitive insights into narrative processing may improve both model design and evaluation, offering more human-aligned storytelling systems. Multimodal discourse theory and social semiotics should also guide narrative modeling to ensure that multimodal content is interpreted as an integrated whole rather than as isolated modes. Theoretical implications of this integration extend far beyond technological applications. Dual coding theory and social semiotics demonstrate that visual and linguistic channels jointly enhance human communication. Multimodal analysis frameworks underscore how meaning is constructed not in isolated words or images, but in their synergistic interplay. Visual narratology reveals the syntax of image sequences, aligning with linguistic models of discourse and structure. Integrating these frameworks with machine learning systems can help bridge the gap between human and artificial narrative understanding, offering not just better models but richer theories of communication itself. In conclusion, the fusion of natural language processing and visual narrative represents a frontier in computational creativity, multimodal communication, and digital semiotics. It offers a model for how machines might engage in storytelling that is emotionally compelling, semantically rich, and culturally relevant. Yet realizing this vision requires deep interdisciplinary collaboration between computer science, linguistics, media studies, cognitive science, and design, anchored in both empirical performance and theoretical sophistication. The next phase of research must not only build better models but also deepen our understanding of narrative as a fundamental structure of human thought and interaction.